So hello everybody, and let me just say how great it is that here you are on a Saturday night. Who does that? Only dedicated students. So Saturday at 5, we're going to look at standard deviation. Yes, I did change that. It was supposed to be sig figs, but I felt like I'd already dealt with that this week. There's a worksheet and there's some notes, and right now I'm just going to move them notes onto my iPad so I can talk from them. So that'll take just a second. In the meantime, if anybody has any questions or comments, you can talk.
No, not right now. Thank you.
Thank you for talking to me. I totally appreciate that. Okay, so we're going to look at standard deviation. And my goal is to give an idea of what it is and when we use it and why. And then to go through some calculations. And I have 3 practice problems for you that are on the handout that I posted on the homepage. So in our class, we learn how to handle sig figs. We make a measurement, and then we use the precision of the tool to come up with a number of sig figs. Or we look at a number that is counted or defined, and we say, well, that's unlimited in sig figs. There's no like imprecision. We know exactly this thing. So when we make measurements, we count sig figs. And then sometimes we make replicate measurements. So for example, this week in your lab, you're going to take some pre-1982 pennies, and you're going to get the mass of one, and then the mass of the second, the third, and the fourth. And in theory, if the pennies were made the same, they should all have the same mass. But what happens is there is a little bit of deviation in the making of them. And also there's some uncertainty in your measurement of that mass. And so when we report an average, like your typical pre-1982 penny has this mass, we're reporting an average of a sample. And then the sig figs for a group, this average, those are determined by the standard deviation. So standard deviation is just a statistics thing that we do when we're trying to say we're reporting an average. I have no idea if that makes sense. I mean, it makes sense to me. I have no idea if that makes sense to you. Okay, but I'm going to keep going, and hopefully if you have questions, you will ask. So standard deviation is a way to report an average, which is the average of a collection of things that we think should all have the same value with correct precision. And correct precision has to do with how many sig figs do we report. So we might report some masses of pennies. The first penny had this mass, and the second penny had that mass, and the third penny had this mass, and the fourth penny had that mass. And then when we come up with what we call the average, we would take those 4 values, 3.1510 plus So I'm going to add those values together and divide by the number, which is, I added 4 things together. Let me divide by 4 to come up with the average. If you have a calculator handy, you could be doing this too at the same time, and that would be a good practice. For what we're doing tonight, you absolutely need a calculator handy. So go ahead and grab one if you don't have one yet. So I have an average that is 3.158225000 grams according to my calculator. The question is, how many digits do we report? And the answer isn't obvious. We're not necessarily going to go 4 past the decimal. Just because each of these went 4 past the decimal doesn't mean the average goes 4 past the decimal. We have to look at where the average is, where those 4 values sort of deviate, where the estimated place would be. And so I might look at this and say, how do I want to do this? They all have a 3 in the ones place. So I'm confident about the ones place. That 3 makes sense. They all have a 1 in the tens place. So I don't even question that 1. That 1 makes sense to represent the average of this group. But this is 5, this is 6, this is 5, this is 6. It's starting to deviate just a little bit here. And the question comes down to, where did it really deviate? Did it deviate in this place or that place? The standard deviation is going to let us know where the values really started to be different. And then the place where they start to be different, we would consider that like the estimated place, and that's where we would last report a sig fig. So even though we have numbers here that are good to 5 sig figs, those numbers are measurements, and each measurement had 4 measured digits and then 1 estimated, so that's appropriate. When we report the average, we might have a different number of sig figs. So that's what a standard deviation does for us. So the first thing is you have to have replicates, and a replicate is just, I'm going to do an experiment that has an outcome, and I expect that when I do the experiment again, I should get about the same outcome. So a replicate is just doing a thing a second, third, fourth, 20, 60, 100th time, but you, based on what you're doing, you would expect the same result. You don't get the same result because there's a little bit of variance. So a replicate is just us repeating trials. And the reason we do that in science is because if we do something once, we can't be confident that's the right answer. We might have made a mistake. And if we do it twice and those 2 answers are similar, we start to have confidence that this is a true answer. And so we do replicates. And in real science, you don't just do something 1, 2, 3, or 4 times. You do something 10 or 30 or 100 times, because you want to make sure that there is a consistency that supports this is a true thing. So replicates come from several trials where we would expect the same outcome. So it's the same experiment. Random error does occur, and it does affect the precision, which is why the measured value might have 5 sig figs, but the fact that things are starting to vary either in the 3rd or 4th digit tells us that the average will have different sig figs. Okay, so I have an example, and it's very basic, and I'm just walking you through the steps. This is, the S stands for standard deviation. So this is us doing some math. Hopefully you have your calculator, and we're solving for a standard deviation. And my goal is to just show you what each of the letters means and how to do this on your calculator. Again, if anybody wants to talk to me, I'm totally down for that. That'd be great. Okay, so here I have 5 values, 1, 2, 3, 4, 5, and these are replicates. I'm expecting that I would get the same result, but there's a little bit of variance. I can see it. 42, 39, 38, 40, 41, they all kind of hover around 40. If I was going to find the average, I would take 42 plus 39 plus 38 plus 40 plus 41, and I would add them all together. I will do that now. And I get a number that has 3 sig figs. So I added them together, but because, and they all were good to the 10s and 1s place, the 10s was measured, the 1s was estimated, but when I added a bunch of things together, I gained in the hundreds place. According to our rules of sig figs, I now have 3 sig figs. And what is the average? It's going to be that number divided by 1, 2, 3, 4, 5. 5 is a counting number, an exact number. And I get up with an average that is 40.0 units, according to the rules of sig figs. But because we have replicates, we're going to determine the sig figs for our average a different way, a better way, a statistical way. So the first thing I need to do is figure out what the deviation is. So here it says the sum of the deviations squared. A deviation is how much one value, and now I'm going to focus just on the first value, how much one value differs from the average. So for our first value, we would say it's 42, and the average is 40.0. It differs by 2 units. So this is 2 more than the average. This is 1 less than the average. This is 2 less than the average. This is the average, and that's 1 more than the average. If I added all my deviations together, they should equal 0. Why? Because an average is the middle of everything. And if I have a number line and this deviates, so I'm going to call this place here whatever the average value is. The first one is 2 more than the average. The second one is 1 less than the average. The third one is 2 more less than the average. The fourth one is bang on. And the fifth one is 1 more. We would expect the deviation from the middle to be 0, because the whole point of the middle is it's in the middle. And I have no idea if that makes sense to you. It's really hard not having you in front of me, because normally I have students nodding or, you know, eyebrows are like this, and then I know there's a question.
Wait, Sue, can I ask a question?
Yes, please do.
Okay, so you know how you divided 200 by 5?
Mm-hmm.
I'm confused why there's 3 sig figs in the answer. Do we just disregard whatever we divide it by?
Right. So the reason here is this was us summing. So capital sigma, Greek S means sum. We were summing all the values. And so those values were measured, and when we added them, we ended up with an extra digit on the left. And then, so that came from measured things. But this one is a counting number. And counting numbers are exact. 1, 2, 3, 4, 5. I had 5 things. To find the average, I need to divide by 5.
Okay. So whenever it's like an exact number on bottom, we just focus on the measured?
Exact number anywhere. We just focus on the measured. Yep.
Okay.
Thank you. I appreciate that. Other questions? Okay. So the whole point of an average is it is in the middle of all the values. And if things deviate a little bit less than or more than, we expect those deviations should add to 0, because the point of an average is it's in the middle of everything. That's why we square it. So now we're going to do this thing. We're going to square things and then square root things. The purpose of squaring it is to make everything positive, and the purpose of square rooting it is to undo the squaring. And so that's what I'm going to do here. 2 squared, so I'm figuring out what this number is squared. 2 squared is 4. Whoops. Negative 1 squared is 1. And then I'm going to add those all together. 4 plus 1 plus 4 plus 1, that's 10. So here for my standard deviation, I'm going to take the square root of the sum of the deviations squared, and I'm going to divide that by the number of trials minus 1. I had 5 trials, minus 1 is 4. So I need the square root of 2.5. 10 divided by 4 is 2.5. Square root that, and I get 1.58. 1138830. My calculator does not understand sig figs. Okay, this next piece is important. I hope you're listening. Come back from the microwave. Come hear me now. Round your standard deviations to 1 sig fig. So the standard deviation for this calculation is 2. What does that mean? It means things are varying. 2 is in the ones place. So things are varying in the ones place by how much? By 2. Our average is 40 plus or minus 2. And then we would put the units next to that, whatever they are. What does that mean? It means the average is 40. But the values in the range might be as high as 42, that'd be plus 2 units, or as low as 38, that would be minus 2 units. So what we're doing is we're reflecting this group of samples and saying the average varies by 2 in the ones place. Again, I have no idea if any light bulbs went on or if there's question marks over your head.
You're good. You're good.
Okay. Well, this is good. And I believe that Michelle would ask a question if she had it, but that leaves another 17 of you not talking to me.
It's making sense. You're good.
Okay, good. Thank you.
So
Yeah.
I had a question for the standard deviation. So would that always just be 1?
The standard deviation is always 1. Thank you, Dimitri. And then where it is determines where you round the number. So because the standard deviation was 2, that means round in the ones place. I'm going to clear this whole board and then pretend some things. Let's say that you had an average that was, so I'm not looking at this data, I'm considering fictitious data in my head. Let's say you had an average that was 1.2345. 6, 7, 8. Like it just goes on and on because your calculator gives you a lot of digits. But when you calculated the standard deviation, you came up with 0.004. What that means is that 1, 2, 3 past the decimal, things start to vary. So I'm going to call that average 1.23, and I'll stop here at 5, this place. Why? Because 1, 2, 3 past the decimal, things are varying plus or minus 4. So this would be a value that most things, if we did replicates, if we did more trials of the same idea, we would expect that to be the average that showed up. But things could be minus 0.004. So we might have a number that was as low as 1.231, or it could be plus 0.004, 1.239. This would be the range that we expect. So the standard deviation is saying this average, but it might be a little lower, this much on one side, and a little higher, the same amount on the other side. Dimitri, did that answer your question?
Yeah, I did. Thank you.
Okay, good. Does anybody else have questions? Because I'm about to add a layer to it, so I want to make sure that we're solid here. So it is hard for students, I have seen over the years, to know, like, why are we rounding things differently? When you look at a measurement, you estimate the last digit. And so if I was making measurements of post 82 pennies on an analytical balance, I would have 4 past the decimal. So each measurement has a certain amount of sig figs that depend on the size of the object and the tool used. But once you make an average of those, the standard deviation is the way to determine where to round. And when you do that, for our previous example, we came up with an average of 40.0, according to the simple rules of add everything up and divide by the number of things. And then we came up with a standard deviation that was 2. And because this is in the ones place, it told us to stop reporting that answer in the ones place. And when we report that answer, we would stop in the ones place because that's where the standard deviation is. And we would say it varies as much as plus or minus 2. So on the high end, we might have 42 as the typical answer, as an answer we would find doing a replicate. And on the low end, we might have 38, which matches the data that we had. They really do range from 38 to 42. So this is the range reflected by this average and its standard deviation. Okay, so what does that actually mean? What it means is 68% of replicates of this exact idea would fall in that range. There might be some replicates that are a little higher and a little lower, but it's possible to be more than a standard deviation away from normal. So now we're going to talk about a bell curve. A bell curve is this idea where we have this perfect curve that is completely symmetrical. And at the center of the curve, we have what we call average or normal. It is the mean. So this value here, in our case, that would be 40. That was the average we reported. But the area under the curve between here and here, if I add all of this up, that's 68%. So 34.1 on the left and 34.1 on the right is 68.2. The area under the curve here is 68.2% of everything, all the possibilities that occur. So when I say 40 plus or minus 2, which means the range is 38 to 42, that is 40 plus or minus 1 standard deviation. 68% of things will fall in that range. Can you have something that is an average plus or minus 2 standard deviations? Sure. If you had an average plus or minus 2 standard deviations, we're now talking about this range. And that would be 34.1 plus 13.6 doubled. That's 95.4% of everything. If you had plus or minus 3 standard deviations, that would be this range. So what I'm referring to is just the area under that curve is 99% of everything. So we had 2.1 plus 13.6 plus 34.1 doubled. That's 99.6. That is most things. So if you ever meet somebody who is 4 standard deviations away from normal, that's a very rare person. That is not typical. The whole idea of a standard deviation is I'm reporting an average that is typical. It's typical, plus or minus 1 standard deviation means it's typical for like 68% of all the chances. Again, I can't see your faces. I don't hear your voices. We need some eyebrow emoticons, and if they're like this, I'll know there's a question. If they're like this, I'll know there's fear. I don't know. If they're like this, you're happy.
Did you say fear?
Yeah, fear. Okay, so I've that's a crazy picture, but so how much of this do you really need to understand? If you're going into science, at some point, you should really understand all of this. What do you need to know for our class? You just have to understand that when we talk about reporting an average with its standard deviation is referring to a range that we would expect to see. The standard deviation always has in our class 1 sig fig, and that sig fig, the place value of it, in this case the ones place, tells you where to round the average. Because this is in the ones place, I'm going to round my average in the ones place. Okay, good. So what we're going to do now is go to the, I have 3 problems for you in the Jamboard, so let me find them. Okay, so, and I have already done these problems and I know what the values are, but even without doing the problems, for example, when you do your penny lab, if you report a standard deviation, I can do it very quickly without writing anything down on my calculator, but I probably don't need to because I can look at the data and know if it seems reasonable. So I want to explain that to you right now, and then I'll set you loose. So here we have some pre-82 pennies, and here's some values. And my goal is for you to report the average and the standard deviation. And when you report it, it should look like this. For the pennies, you would report the average. We're looking at grams, and that's a mass. And the bar above mass means I'm reporting a group, the average for a group, or the mean. And you're going to come up with an average. And then, so that's what the calculator gives you. And then you're going to come up with a standard deviation. And this one happens to be 0.001. I've already done it. And then if this is 1, 2, 3 past the decimal, that's the last place you're going to report. So what I expect the group to come up with is something like this.
So I don't think we could see anything.
Oh, I see your point. Hang on. I love it when you talk to me. It really helps. There we go. So when you report your average mass, you're going to say, here's the average, plus or minus, 1 standard deviation, and then the units. And it looks like that. So there are 3 of those. One is the mass of some pennies, and these may not be the masses of your pennies, certainly, because your pennies are only good to centigram, the hundredths of a gram place. But it's a chance for us to practice. The values will be about 3.1 or 3.2 grams, and we're practicing doing a standard deviation. And then here we have some densities, same thing. You're going to find the average. You're going to see where the average varies according to the standard deviation, and then you report it in a way that says average plus or minus standard deviation, units, and put a box around it. And then the last one would be if you had used a micropipetter to pipette 5.5 mil aliquots of water, these are some masses you might have come up with. So the point of this is when you come up with the average, you're going to have 4 or maybe 5 sig figs according to the rules of sig figs. But once you figure out the standard deviation, it probably is going to bring down the number of sig figs. For example, here, all the answers are the same in the tenths place, they're all 4. All the answers are the same in the hundredths place, they're all 9. But they start to vary in the thousands place. So probably your standard deviation is going to be a number in the thousands place, and that'll determine how you round the average. Questions? No questions. Okay, I'm going to break you into groups. There are 18 of you, so we'll do 3 groups. You probably are going to want to just download the standard deviation practice and do it by yourself, and then compare answers. And if you write answers differently, talk about how you present the answers. So I really think that you're going to want to do this work on your calculator by yourself, and then use your group when you have questions about how to do the calculation on your calculator. And then compare answers, because there is one right answer for each of these questions. So if you and a friend have different answers, somebody's not right, and you need to figure out who's right and why. Okay, when we're done with the breakout rooms and you have 3 answers that you're ready to report, and I probably will check in and say yes or no, you can just be done and leave, and then I will see you sometime next week.